Okay, again, we're still in Chapter 6. We're looking at Section 6.6. We're going to simplify complex rational expressions. So scroll back. First, find the LCD of all the denominators for all of the rational expressions occurring within both the numerator and the denominator. Then multiply by 1 using the LCM over LCM, and if possible, by removing a factor of 1. So, for example, let's look at the numerators of both of these. What are the factors that all of these would go into? You have a 2, a 4, a 3, and a 4. So what is the LCD of all of them? Very good. It would be a 12. It would be a 12. So if you multiply this top by 12 and you multiply the denominator by 12, I know they're complex fractions. This is what we're going to look at. So we now have 1/2 plus 3/4 times 12 over 2/3 plus 1/4 times 12. What we're doing is we're going to clear up these fractions, and it kind of makes it look a little easier or a little better to work with. So this is saying 1/2 times 12 over 1 plus 3/4 times 12 over 1 all over 2/3 times 12 over 1 plus 1/4 times 12 over 1. And then we just go from there. So 2 goes into 12 how many times? 6 times. So that leaves a 6 here. 4 goes into 12 3 times, so 3 times 3 is 9. 3 goes into 12 4 times, so 4 times 2 is 8. And then 4 goes into 12 3 times, so 3 times 1 is 3. This simplifies to 15 over 11. So that wasn't too hard, was it? It sounded harder than it was. So let's look at the next part and see what the LCD is in this one. The LCD is X. So again, we are multiplying the top and the bottom both by X. Okay, so we're really saying 1 times X plus 1 over X times X. 1 times X minus 1 over X times X. So let's clean up and use distributive law first. So I wind up with, okay, the X here and here cancels. So it gives us a plus 1. So now I have X plus 1 in the numerator. This X and this X cancels. So now I have X minus 1 in the denominator. And we're done. Okay, what do you think our LCM on this one is? Is it X to the third? Or X, or just X? Very good, it's X to the third. Everything has to go into it. We've got to have at least the highest power. So, if we multiply the top by X to the third and the bottom by X to the third. So we wind up with 6 over X to the third times X to the third over 1 minus 2X squared times X to the third over 1. All of this is over 3X times X to the third over 1 plus 4X squared times X over 3 over 1. Now we're just going to simply start cleaning up. These X thirds cancel, so we get 6. This becomes X to the first. So now we have minus 2X over, this cancels here and becomes X to the second, if I can get my stylus to work. So that gives us 3X squared. And then this cancels here and here and leaves just an x. So we get plus 4x. Now, do we see if we can simplify anything? Yeah, we're always going to try to factor something out to see if we can simplify. So the GCF of 6 minus 2x is going to simply just be 2. And then we're going to wind up with 3 minus x. And in the denominator, I have simply just an x. So now I'm left with 3x plus 4. And nothing cancels. So that is your final answer. Okay, adding the numerator and the denominator. We're going to do like we've done in the past. To simplify a complex rational expression, add or subtract is necessary to get a single rational expression in the numerator. Add or subtract is necessary to get a single rational expression in the numerator. Divide the numerator by the denominator. If possible, simplify by removing the factor of 1. We're just going to do like what we did before. Okay? Now, the way I rewrite this is I say x over x minus 4 divided by 2x, divided by 3 over 2x minus 8. Now you remember that phrase, keep, change, flip. That's what we're going to do. We're going to keep the first one. So we still get x over x minus 4. We're going to change it to multiplication. So now we get 2x minus 8 over 3. Then we're going to factor. So now you're going to have x over x minus 4 times, we're going to factor out a 2. So I get 2 times x minus 4 over 3. And then we're going to start canceling out anything that we can cancel. So now I wind up with 2 times x over 3. And that is our final answer, 2 times x over 3. And we're done. Again, we're going to do the same thing. We're going to do the keep, change, flip. And see what we can do from there. Sometimes you may have to find common denominators. Okay, let's look at this first one. We have 5 plus x over 3 being divided by 4x minus 1 over 2x. So I'm going to look at each one of these separately. Let's look at this one. What does these not have in common? They don't have the same denominator, do they? But if we multiply this one, the denominator, by 3 here, and the numerator by 3, we wind up with 15 over 3 plus x over 3. So that gives me 15x over 3 being divided by, these don't have the same denominators either, do they? So if we multiply this by 2 and this by 2, we get 8 over 2x minus 1 over 2x. And that combines, 8 minus 1 is going to give me 7 over 2x. So now we're going to do the keep, the change, and then the flip. And see if there's anything that we can cancel out of there. I don't see anything that we can cancel out of that. Oh, I did make a mistake. It's not 15 plus x. It is actually, it's not 15x, it's 15 plus x. Let me rewrite this real quick, because that does make a difference. So it's 15 plus x, and the same thing here. So now we have 15 plus x over 3 times 2x over 7. All right. So now we're just going to follow the rule of thumbs. So 2x times 15 is going to give me 30x. And then 2x times x is going to give me 2x squared all over 21. Because 3 times 7 is 21. Now, if we were to factor out, we could, but if you notice what happened here, nothing here canceled. And if we tried to factor this problem out, if we tried to factor these out, we're going to wind back up with what we had. So there's nothing really to factor. You're done. So that is the end of this section.